Hello students, here in this 24th point of trigonometry, I am going to establish three very basic and standard important identities of trigonometry. And all these identities, standard trigonometric identities, are dependent on the Pythagorean result. See, I think you are all familiar with the Pythagorean result. If we have a right angle triangle, see in the right angle triangle, the square of the hypotenuse is equals to the sum of the squares of the other two sides of the triangle. So, if you have a look at this, we know that, see, sin theta, cos theta, tan theta, their definitions. Sin theta is the y coordinate by r, cos theta is the x coordinate by r, whereas tan theta is the y coordinate by x coordinate. For any angle, we need to take a point P on the corresponding terminal ray. With that point P, we will easily identify x, y and r. With that x, y and r, we write these trigonometric ratios. And that x, y and r, in all the cases, for sure it forms a right angle triangle like this. Yeah. Now, see, look at this right angle triangle. See, for our convenience, I took the angle theta which lies in the first quadrant, and it may be see an acute angle I consider. The similar discussion is true for any type of angle, for any angle. Okay, it may not acute. For that also we have a Pythagorean result for that, and then we can establish these identities. Okay, here in particular, for our convenience, we are discussing with the acute angle theta, and for sure, see, this theta, this y, x and r will form a Pythagorean result. Yeah, what is a Pythagorean result? I think we are all familiar that the square of the hypotenuse, here in particular, r is the hypotenuse because it is opposite to 90. And x and y are the see, other two sides of the right angle triangle. So r square is equals to x square plus y square. Right. So this is the Pythagorean result. And now see, to convert this Pythagorean result in terms of the trigonometric ratio, I am going to divide this Pythagorean result with either with r square or with x square or with y square. First of all, see, you just take it as 24a. Here I am dividing the whole Pythagorean result with r square. Then what will happen? See, if I divide with this with r square, so this is equals to r square divided by r square is equals to x square by r square plus y square divided by r square. And here in the left side I have it as 1, and whereas in the right side x by r whole square plus y by r whole square. Now see, the left side is this 1, okay, and whereas coming to the right side, x by r whole square plus y by r whole square. See, what is y by r? And in particular, y by r is sin theta and x by r is cos theta. You just use that sin and cos in the place of y by r and x by r. Then it becomes like this. This implies sin square theta plus cos square theta is equals to 1. This is sin theta, it's a square. This is cos theta, it's a square, is equals to 1. So at the end, what I have? I have sin square theta plus cos square theta is equals to 1 for any angle theta, right? See, theta may be any angle, okay? Theta may be any angle. In all those cases, sin square theta plus cos square theta is equals to 1, okay? For example, if you take an angle in the place of theta, sin square 117 degrees plus cos square 117 degrees is how much? See, we don't know the exact values for sin 17 as well as cos 17, but sin square 17 plus cos square 17 is always 1. The angle may be larger also. For suppose sin square of minus 2020 degrees plus cos square of minus 2020 degrees. Again it is 1. See, you just don't pay your attention on the angle. Angle should be same in these two terms. And the format is in the form of sin square of that angle plus cos square of the same angle is equals to 1. So, for any value of the angle, for any value of theta, always we have one wonderful tool in our hands to solve many problems easily, is that sin square theta plus cos square theta is equals to 1. Right? And then further we just rearrange this to get different ideas. Okay? See, I will erase this. and I will take this sin square theta plus cos square theta is equals to 1, and I will show you how this sin square theta plus cos square theta is equals to 1 is again gets different transformations, right? See, first of all, you just once again you just pay your attention here. See, this is the Pythagorean result. You need to divide with r square, and then this is 1 in the left side, whereas in the right side x by r whole square plus y by r whole square, and that is sin square theta plus cos square theta is equals to 1, and there you have this. And now, yeah, I am starting with this sin square theta plus cos square theta is equals to 1. You just look here. See, sin square theta plus cos square theta is equals to 1. That's a good thing. See, you just make, yeah, we have sin square theta plus cos square theta is equals to 1, and in the required cases we can rewrite it like in different ways. Just have a look there. See, in one way you just make sin square theta as subset. It will become like sin square theta is equals to 1 minus cos square theta. Is it right? Yeah. And in the other way you just make cos square theta as subject. So cos square theta is equals to 1 minus sin square theta. Now see here, sin square theta is equals to 1 minus cos square theta, and I will rewrite it like this. Sin theta into sin theta is equals to this 1 minus cos square theta as 1 minus cos theta into 1 plus cos theta. And now if you rearrange it, you just send any one of these two terms to the left side and one sin theta to the right side. It becomes like this: sin theta divided by 1 minus cos theta is equals to 1 plus cos theta divided by sin theta. Or in other way, if you write 1 plus cos theta here, you will get 1 minus cos theta there. See, this type of changing, this type of rewriting is possible for this cos square theta is equals to 1 minus sin square theta also. Okay, so sin square theta plus cos square theta is equals to 1 we need to memorize, and from there we have a chance to write this type of statement also. Not only this, in the required cases you just make sin square theta as subject and you write sin square theta is 1 minus cos square theta, and in other cases you will write cos square theta is equals to 1 minus sin square theta. Whereas if cos square theta is 1 minus sin square theta, then what to say about cos theta? Cos theta is the square root of 1 minus sin square theta. Is it right? Just have a look here and just pay your attention, and then I will give you the next idea. Look there. Now the next idea, again I am starting with the Pythagorean result, and that is r square is equals to x square plus y square. And now here, as in the previous case, we divide this total Pythagorean result with r square. Now in this case B, I am going to divide the total expression with either x square or with y square. So for suppose if you move with x square, what will happen? So in the next step, I will write it like this: r square divided by x square is equals to x square divided by x square plus y square divided by x square. See, here we are dividing with x square. See, division with a quantity is possible only if that quantity is non-zero. So this division is possible if x is not equals to 0. You need to identify that one, okay? And then see, treat that x is non-zero and that this division is possible. This implies this r square by x square is nothing but r by x whole square is equals to 1 plus this y square by x square is nothing but y by x whole square. And in the next step, how can you write? See, look there, r by x. See, we know that r by x is just nothing but what? Secant theta. Because cos theta is x by r, then for sure it is secant theta. So secant theta square is secant square theta is equals to 1 plus y by x whole square. See, what is y by x? Y by x is tan theta and its square is tan square theta. At the end, secant square theta is equals to 1 plus tan square theta, and then we will rewrite it like this: secant square theta minus tan square theta is equals to 1. So, see, secant square theta minus tan square theta is equals to 1 is another wonderful identity, yeah, which we use repeatedly, right? And this secant square theta plus tan square theta is equals to 1 is also true for all the values of the angles except the angles for which x is 0. See, this discussion is true if x is non-zero. What happens if x is 0? See, if x is 0, then there are some angles corresponding to that x0, and for those angles, this secant square theta minus tan square theta is equals to 1 is a failed statement. In all the other cases, it's a true statement, right? See, you just look there, whenever x is 0. Here if you look there, x is what? This horizontal distance is usually the x. And see, x0 in the sense x coordinate is 0. X coordinate is 0 on y-axis. So, if theta is on y-axis, this is failed. So, this is true if for all theta except on y-axis. You just look there. I will give you a few examples where theta is on y-axis. Then on those cases, this secant square theta minus tan square theta is equals to 1 is a false statement, and in all the other cases, it's a true statement. And in generally, we go with the acute angles. In generally, we consider this as a true statement because it is true for many angles and it fails for few angles. And you need to memorize that this is a false one for the theta where it lies on the y-axis, where it lies on the vertical line. Okay. See, once again, just look there. We started our discussion with the Pythagorean result that r square is equals to x square plus y square. Here I am dividing everything with x square. Then r by x whole square is 1 plus y by x whole square. This r by x is secant square theta. Y by x is tan square theta. So secant square theta minus tan square theta is equals to 1. And this is true for all the theta except theta lies on the vertical line, and that vertical line is specifically y-axis. And now I will give you a few examples. If anybody asks you the value of, what I am going to tell you is secant square of something like, you may say anything, 327 degrees minus tan square of 327 degrees is equals to 1. See, you don't pay your attention on the angle, you just pay on the format. Secant square of an angle minus tan square of the same angle is always what? 1. That's the good thing. And another thing is y-axis. For y-axis is a failed statement. For y-axis, see, the angles are corresponding to 90 degrees above positive y, 270 degrees negative y, like that. For example, if anybody asks you to give the value of secant square 270 minus tan square 270, then in this case, this value is not 1, it's a wrong statement actually. Why? Because for 270 degrees, x value is 0. Since x value is 0, secant 270 as well as tan 270, both the values are infinity. This is an infinity, unknown larger. This is also infinity, unknown larger. See, infinity minus infinity is an undefined, indeterminate form of mathematics, in mathematics, okay? Not only in mathematics, usually infinity minus infinity is an indeterminate thing. That's why this value won't exist. So, see, if anybody asks you like this, you need to say that its value is indeterminate. In all the remaining cases of this format, its value is what? 1. Is it clear? And see, for example, what you say the value of tan square 1000 degrees minus secant square 1000 degrees. Yeah, tan square 1000 degrees minus secant square 1000 degrees is absolutely what? Minus 1, because secant square theta minus tan square theta is 1. Secant square 1000 minus tan square 1000 is 1. And here I am asking you for about tan square 1000 minus secant square 1000, and that is again minus 1. Okay, this is minus 1. So these are the simple examples related to the secant square theta minus tan square theta is equals to 1. And now once again, if you look that secant square theta minus tan square theta is equals to 1 in different manner. See, if you are ready to rearrange it, what we have exactly, secant square theta is equals to 1 plus tan square theta is the generated statement. And if you rewrite it, in one case, I will make 1 as the subject, and that in particularly secant square theta minus tan square theta is equals to 1. And in another case, I will write it like this, secant square theta minus 1 is equals to tan square theta. See, these two statements are again somewhat important to memorize. Secant square theta is equals to what? 1 plus tan square theta, whereas tan square theta is equals to what? Secant square theta minus 1. And here in particular, secant square theta minus tan square theta is equals to 1. Again, if you are ready to rewrite, you have a chance to write it like this. Secant square theta minus 1 is just nothing but secant theta minus 1 into secant theta plus 1, whereas this side it is tan square theta, tan theta into tan theta. Send one tan theta this side and one term among these two that side, it becomes like this. Secant theta minus 1 divided by tan theta is equals to tan theta divided by secant theta plus 1. Yeah, see, likewise we will rewrite this secant square theta is equals to 1 plus tan square theta. And this side we will generate a very important one. See, secant square theta minus tan square theta is 1. Yeah, now I have a chance to write it like this. Secant theta minus tan theta into secant theta plus tan theta is equals to 1. Left side you need to use that a square minus b square formula. Secant square theta minus tan square theta, secant theta minus tan theta into secant theta plus tan theta. Yeah, and now it is very clear that secant theta plus tan theta is equals to 1 by secant theta minus tan theta. That in the sense, if you pay your attention here, this secant theta plus tan theta and secant theta minus tan theta are reciprocal to one another. If one value you know it as some, say something some like p, then other value is 1 by p. Is it clear? So you just pay your attention related to this second identity, secant square theta minus tan square theta is 1. Okay, just look there. Yeah, now this is the third trigonometric identity. Again, it can be generated from this Pythagorean result that r square is equals to x square plus y square. In the first case, we divide this total relation with r square, and in the second case, we divide with x square. Here clearly we need to divide with y square. So r square divided by y square is equals to x square divided by y square plus y square divided by y square. Yeah, see, as we discussed in the previous cases, it is very clear that r square by y square is r by y whole square, okay, and which is what? Cosecant square theta. This is equals to x square by y square is x by y whole square, and x by y is cot, so this is cot square theta, plus this y square by y square is equals to 1, and cosecant square theta is equals to cot square theta is equals to 1. So this is the statement now. If you rewrite it, you have a chance to rewrite it like this: cosecant square theta minus cot square theta is equals to 1. And you just think once, see, since we are dividing with y square, here you need to mention that this division is possible only if y is not equals to 0. As per the definitions, y is nothing but y coordinate. That y coordinate is not equals to 0, then it is true. If that y coordinate is 0, then this is a false statement. So whenever y coordinate is 0, y coordinate is 0 on x-axis. So this statement is true. Okay, this is true for all theta except theta on x-axis. Because if the angle theta is corresponding to x-axis, then the y value, y coordinate value is 0. Then in those cases, this relation is a false one, and in the remaining cases, this is a true statement. So at the end, you need to memorize that this cosecant square theta minus cot square theta is equals to 1. So to mention few examples related to this, you just take any angle as you wish in the place of theta, and clearly it gives a value 1. So for suppose if I say cosecant square of 1 to 7.5 degrees minus cot square of 1 to 7.5 degrees, and clearly its value is 1. See, you just don't pay your attention on the angle, you just pay your attention on the format. For any angle, this cosecant square theta minus cot square theta is 1. If that angle theta is related to x-axis, then you need to think. See, x-axis is the horizontal line. Then the angles corresponding to horizontal line are the even multiples of 90, say 0, 180, 360, like that. So for example, if I have this cosecant square of 720 degrees minus cot square of 720 degrees is again an indeterminate thing, because say 720 degrees is corresponds to positive x, where the value of y is 0. Since y is 0, cosecant 720 is infinity, whereas cot 720 is also infinity. Infinity minus infinity is indeterminate, and that's why it is an indeterminate value, a unknown value. See, it's actually not possible, right? Then See, for all the remaining angles except that theta on x-axis, this is a true statement. Okay, so cosecant square theta minus cot square theta is equals to 1. And again we have the chances to rewrite this cosecant square theta minus cot square theta is equals to 1 as per the requirements. Okay, I will directly mention you that, see, cosecant square theta minus cot square theta is equals to 1. If you rewrite it in one case, as we discussed in the previous B, cosecant theta minus cot theta is equals to 1 divided by cosecant theta plus cot theta. That in the sense, again these two are reciprocal to one another. And in the other case, if you send one this side, cot theta this side, we have a chance to rewrite it like this. Cosecant theta minus 1 divided by cot theta is equals to cot theta divided by cosecant theta plus 1. Just a rearrangement, see, as we discussed in the B as well as in A. Okay, so at the end, from this 24th point, we have three wonderful trigonometric identities in our hands, and usually we memorize them as sin square theta plus cos square theta is 1, secant square theta minus tan square theta 1, cosecant square theta minus cot square theta 1. Using these three identities, we can generate some more, see, miraculous problems. We can solve many problems, right? So just have a look. Yeah, at the end, see, don't forget to share this videos for your friends. Okay, see, if they are useful for your friends, then it is very good for you as well as for your friends also. Okay, so do like it, share it as well as comment it, right?